Hello, viewers. In today's session, we are going to discuss a very important and conceptual problem from definite integrals, right? And in this lecture, we are going to solve this definite integral involving the two most important functions in mathematics, right? That is the mod function and the signum function. So here we have to evaluate this integral from minus 3 by 2 to half, and the integrand is mod of 1 minus x times e raised to signum of sine inverse x, right? So here we see an important function inside the signum function, that is the inverse trigonometric function, right? So here to evaluate these kind of integrals, what we usually do, we take separately the signum function and the mod function, right? Or in other words, we can say that we have to apply the definition of mod function and signum function to this integrand, so that we can simplify the integrand, and then we can integrate the function, right? So let us see how we can apply the definition of signum function and mod function to this integrand, along with the inverse trigonometric function. So viewers, here will first of all take this sine inverse x, right? Now see, from inverse trigonometric functions, we know that the principal value branch of sine inverse x is given by the interval that is minus pi by 2 to pi by 2. It implies that sine inverse x belongs to this interval, right? That is from minus pi by 2 to pi by 2, and we know that the approximate value of pi is 3.14. So we can also write this interval as minus 1.57 to 1.57, right? Okay, now let us quickly see the definition of signum function. So signum function is defined like this: signum of x is given by plus 1 whenever x is greater than 0, and signum of x is 0 whenever this x is equal to 0, and signum of x is minus 1 whenever x is less than 0, right? And here we have the mod function. So the mod of p is defined like this, that is, the mod of p is positive p whenever p is greater than 0, mod of p is 0 whenever p is 0, and mod of p is negative p whenever p is a negative quantity, right? So here we see that to evaluate this definite integral, we need these three concepts, and we'll apply one by one these concepts to this integral. So now let us call this integral as I, and here the lower limit is minus 3 by 2, and the upper limit is 1 over 2. So let us plot these limits on the real number line. So here we have 0, here we have minus 1, here we have minus 2, here we have 1, right? So minus 3 by 2 is minus 1.5. So here we have minus 3 by 2, and 1 over 2 is 0.5. So here we have 1 over 2, right? So now let us consider this function, that is e raised to signum of sine inverse x, right? Now see, here we have sine inverse x belonging to this interval minus pi by 2 to pi by 2, right? So when sine inverse x goes from minus pi by 2 to 0, then the value of sine inverse x is negative, right? Because when sine inverse x belongs to the interval minus pi by 2 to 0, then sine inverse x is negative. So it implies that we have e raised to signum of a negative quantity, right? So sine inverse x is negative in this interval, that is minus pi by 2 to 0, and this interval is same as minus 1.57 to 0, right? So we have a signum of a negative quantity, right? And when x is negative, that is x less than 0, then signum of x is minus 1, right? So now we have e raised to minus 1, right? That is equal to 1 over e. So let us quickly revise it. We consider this function e raised to signum of sine inverse x, and sine inverse x is a negative quantity in the interval minus pi by 2 to 0 or minus 1.57 to 0. So it means here we have a negative quantity, and signum of a negative quantity is equal to minus 1, because the signum of x is minus 1 whenever x is less than 0, right? So signum of negative quantity is equal to minus 1. So we have e raised to minus 1, that is 1 over e. So now let us consider the interval that is when sine inverse x belongs to the interval 0 to pi by 2, right? And 0 to pi by 2 is same as 0 to 1.57, right? So whenever sine inverse x belongs to this interval, that is 0 to pi by 2, it means sine inverse x takes the positive values, right? So in that case, e raised to signum of sine inverse x, right? So in that case, e raised to signum of sine inverse x can be written as e raised to signum of a positive quantity whenever sine inverse x belongs to this interval, right? Because this interval contains all the positive values. So we have positive values here, right? And we know that signum of x takes the value plus 1 whenever x is greater than 0. It means whenever x is a positive quantity. So here we have e raised to plus 1, right? Because signum of a positive quantity is equal to positive 1. So we have simply e raised to 1, right? So now let us split this integral at this point, that is x is equal to 0, right? So we have I is equal to minus 3 by 2 to 0. Here we have mod of 1 minus x e raised to signum of sine inverse x, and here we have dx plus 0 to half, and we have mod of 1 minus x e raised to signum of sine inverse x, and here we have dx. So now in the first integral, we see that the limit of integration vary from minus 3 by 2 to 0, right? From minus 3 by 2 to 0. And this term, that is e raised to signum of sine inverse x, is equal to 1 over e, that is e raised to minus 1, right? Because see, sine inverse x goes from minus pi by 2 to 0, because here we have minus 1.57, right? And here we have minus 3 by 2, that is minus 1.5, right? So here we have minus, this point is minus pi by 2, right? So when we go from minus pi by 2 to 0, that is from this point to this one, then sine inverse x is negative, as we have discussed already. So the value of e raised to signum of sine inverse x is equal to e raised to minus 1, that is 1 over e, right? And in the second integral, we have the limits from 0 to half, right? And when we go from 0 to half, then we have here sine inverse x belonging to 0 to pi by 2, that is 0 to 1.57. So 1.57, it lies somewhere here, because here we have 2, and here we have 1.57, right? So when we go from 0 to half, then sine inverse x is positive. So the value of e raised to signum of sine inverse x is equal to e raised to 1. So here this value is e raised to 1. So now our integral I can be written as from minus 3 by 2 to 0, and we have mod of 1 minus x, and here for this term we have 1 over e dx, and then we have 0 to half, and here we have mod of 1 minus x, and we can now write for this term e, and here we have dx. So now we have to take care of this mod function, right? Now see, when x goes from minus 3 by 2 to 0, then all the values of x are negative, right? So when we calculate 1 minus x, then 1 minus x is always a positive quantity. So mod of 1 minus x in this case is positive 1 minus x, because the mod of p is plus p whenever p is greater than 0, right? So for all values of x uh, going from minus 3 by 2 to 0, the value of mod of 1 minus x is positive 1 minus x, and in this case a mod of 1 minus x is again positive 1 minus x when x goes from 0 to half, right? Okay, so now here we can now write I is equal to minus 3 by 2 to 0. Here we have positive 1 minus x, 1 over e dx, and then we have 0 to half, and here we have positive 1 minus x and e dx. So now we can write this integral I as taking 1 over e outside the integral. We have minus 3 by 2 to 0, 1 minus x dx, and then taking this e outside the integral, we have 0 to half, and here we have 1 minus x dx, right? So now we have 1 over e. Now the integral of 1 dx is simply x, and the integral of x is x square over 2, and limits of integration are from minus 3 by 2 to 0, and here we have e, and here we have again x minus x square over 2, and limits are from 0 to half, right? So now substituting the limits, first we'll take x is equal to 0. So here we have 0 minus 0, that is simply 0, and then we take x equal to minus 3 by 2. So we have minus 3 by 2 minus, this is 9 by 8, because here we have minus 3 by 2 square. So the entire term is 9 over 8, right? Okay, then we have e, and now we take x equal to half here. So we have half, then we have minus 1 over 8, right? Okay, so now we have 1 over e, and here minus, when we multiply these two terms by this negative sign, we have simply 3 by 2 plus 9 by 8, and here we have e, and this is half minus 1 over 8. So now we can easily get the values of these two expressions. So we have I, this is 1 over e, and here we can take the LCM, this is 8, then we have here 12 plus 9, and here we have e, and 8 is the LCM, so we have 4 minus 1, right? So this is 21 over 8e, and here we have 3e over 8, right? So where's the value of this integral is given by 21 divided by 8 times e plus 3 times e over 8, right? And we can also express this expression as 3 by 8. We can take 3 by 8 common, then we have e plus 7 over e, right?